This is 6.3, example 2, letter B. So on this problem, they want us to, it says find P of y, and this time y is equal to -2. So we're going to plug in -2 for every time we see a y. Make sure you use your parentheses. So we are going to raise -2 to the third power. So -2 cubed is -8. So 5 times -8 plus -2 squared is +4. And then -3 times -2 is +6. So 5 times -8 is -40 plus 4 plus 6 plus 8. -40 plus 4 is -36. -36 plus 6, -36 plus 6 is -30. All right, so that looks right. I was thinking that was not right, but I think it's right. Yep, -22. All right, now on this problem, they want us, once again, they said find f of x for f of a plus 7. Well, a plus 7, do you see it's in the place of x right there? So I'm going to plug in this whole value for x in this equation. So 3 times x, well, the value of x is a plus 7 minus 13. So I'm going to contribute that 3. So 3 times a is 3a. 3 times 7 is +21. And I don't have to distribute that. Excuse me, I almost messed that up. All right, so my only two like terms are 21 and -13. So my final answer is 3a plus 8. All right, moving on. All right, so here on our practice problems, it says that we're going to combine like terms, state the degree, and the type of polynomial. So you're going to start with your biggest exponent. So my biggest exponent is 3. So I have 8x to the third minus 1x to the third. So 8 minus 1 is 7, x to the third. I have a couple of x squares. -3x squared plus 3x squared is 0. Those are gone. And then I have plus 5. So after combining like terms, I have two terms. So I have a binomial. The degree is 3, because that's my biggest exponent. So I would say it's a third degree binomial. And if it asks, what is my leading coefficient, the answer would be 7. Y'all can hear my dog crying. He's in his little cage next to me, so he won't knock my recorder off my stand. All right, so number 2, I have an exponent of 4, 2 of those. So 5y to the 4th plus 1y to the 4th is 6y to the 4th. And then I have a couple of exponents of 2, so I have -3 plus 2 is -1, so minus y squared, and then plus 4. I end up with 3 terms, so I have a fourth degree trinomial, and my leading coefficient is 6. Number 3, it wants me to find P of 3. In other words, I want to put in 3 for all of my x's, and then it wants me to find P of -1. So the first thing is my 3 right here. So 3 squared minus 5 times 3 minus 5. So 3 squared is 9. 5 times 3 is 15 minus 5. So 9 minus 15 is -6. And -6 minus 5 is -11. All right, so now it wants me to find P of -1. So make sure you put those, especially when they're negative numbers, in parentheses. So for right here, I'm going to put -1 squared minus 5 times -1 minus 5. So -1 squared is +1. -5 times -1 is +5. And I know that 5 minus 5 is 0, so my final answer is 1. All right, on our practice problems. Oh, that was our practice problem answers. So look, yep, it looks like we got them all right. Awesome. All right, so my next Hawks type problem would be from Hawks Practice 6.3a. My first question is this expression, the question is this a polynomial? Well, the answer is no, and the reason it's not is because I put the expression contains a negative or fractional exponent. So for any of your expressions, if you have a negative exponent in any term or a fraction, the answer is no, it's not a polynomial. Then it gives me a whole number 9. Is 9 a polynomial? Well, can you write this number with an exponent that's a positive number and it's a positive whole number? Well, the answer is yes. 9 can be written as 9 to the first power. This expression does not contain a negative or fractional exponent. So the answer is yes. The next practice problem I found in my practice Hawks examples was one like this one. So the directions first it asks, is this a polynomial? Well, I don't see any fractions or negative exponents, so the answer is yes. And then it asks what type, state the degree, and the leading coefficient. So I have 3 different terms, which makes it a trinomial. The degree, my biggest exponent is a 2, and the leading coefficient is 5. So I would say it's a second degree trinomial, and the leading coefficient is 5. All right, so then it gives us another problem where we are putting an expression in for our variable. So it tells me to find f of a plus 8. That means I am going to substitute that whole expression for my x right there. So f of x would be -4 times a plus 8 plus 6. So I'm going to distribute that -4. So -4 times a is -4a. -4 times 8 is -48. And I bring down my plus 6. Oh, sorry, that's not -38. That's -32. Silly. I'm so distracted at my house. I'm sorry. People are coming and going. Amazon is getting delivered. My dog is whining. Y'all just bear with me, please. Anyway, so when I combine my like terms, I get -4a minus 26, and that is the final answer. All right, so now that takes us into section 6.4. All we're doing in this section is adding and subtracting polynomials. That's pretty easy. All right. All right, I can't find my example problems. All right, I had recorded this earlier. I messed up at the end because my camera fell, but now I don't think I recorded. Oh, sorry, it was still on my printer. Oh my word, they're gonna fire me. All right, so anyway, moving on. So like I said, all we're doing in this little section is adding and subtracting polynomials. So when you have numbers in a set of parentheses, well, if there's a plus in front of the set of parentheses, nothing changes. Basically, you can just rewrite this whole long expression and drop all of those parentheses without changing anything. Now in a minute when we do subtraction, that's a little different. So just for the sake of room, I'm not going to rewrite it without parentheses. So the only thing I have to do is combine like terms. So you're going to want to start with your biggest exponent. So my biggest exponent is 3. So I have 5x to the third plus 4x to the third, and I get 9x to the third. And since this is so long, I'm going to mark them off as I write them down. Now I have x squared. So I have negative 8x squared, negative 2x squared, and that's all my x squares. So I'm going to have negative 8 combined with negative 2 is negative 10x to the second. Now I have just some x's. So I have positive 12x combined with negative 5x. So 12 combined with negative 5 is positive 7x. Then I have a few constants. So 13 minus 8 is 5, and 5 plus 14 is positive 19. So that is my final answer. I have a polynomial with 4 terms. It's a third degree polynomial, and my leading coefficient is 9. All right, number 2, do the same thing. There's a plus symbol there, so I could just drop all those parentheses and just combine like terms. So I have 1x to the third plus 4x to the third. That's 5x to the third. Then I have negative 1x squared plus 5x squared. Well, negative 1 plus 5 is positive 4x squared. 5x combined with negative 8x, 5 minus 8 is negative 3x. And then I have a constant plus 9. And I am finished. Now, when you have a negative in front of a set of parentheses, that's just like multiplying this whole set of numbers by negative 1. Since there's a negative 1 right there, I have to distribute that negative number, that negative 1, or that negative sign to everything in the parentheses. Now, the first set of parentheses, I don't have a negative sign, so I'm just going to rewrite those terms just exactly as I see them. So the opposite of 5x to the fourth is minus 5x to the fourth. The opposite of negative 2x to the third is positive 2x to the third. That becomes plus 5x squared. And that becomes minus x. All right, now that I've dropped all my parentheses, I've distributed my negative sign. Now, just like the other problems, I'm going to combine like terms. So I have 9x to the fourth combined with negative 5x to the fourth. So 9 minus 5 is 4x to the fourth. Then my 3's, I have negative 22x to the third plus 2x to the third. So that's a negative 20x to the third. Now I have 3x squared plus 5x squared. So that is 8x squared. Negative x to the first power plus 10. And that's my long all right. Now, number 4, I would never leave a problem like this. I would rewrite it just for the sake of time and the sake of room. I'm not going to rewrite it with those parentheses, but when I rewrite it, I'm going to go ahead and distribute that parentheses to everything, okay? So the first expression, as it were, has nothing in front of it, so I'm just going to write 8x to the third plus 5x squared minus 14. And now I'm going to say the opposite of negative 2x to the third is plus 2x to the third minus x squared minus 6x. All right, those parentheses are gone. I'm combining like terms. So 8x to the third plus 2x to the third is 10x to the third. And then I have 5 minus 1, which gives me 4x squared I have an x to the first over here, so minus 6x, and then minus 14 is the right answer. And I've written that in descending order according to the exponents. All right. So here's some extra practice problems. So I think it's a good idea if you guys would pause the video, work those out, and then check back in and see what I got on mine when I did mine. Make sure you get the right answer. Adding, there's nothing to change. So I'm going to start with 3x to the second. I'm going to combine 15x minus 9x. So I get, what is that, 6x. And then 4 combined with negative 5 is minus 1. I'm done with that one. On subtraction, I got to distribute that negative sign. So on the first parentheses, I'm going to rewrite it exactly like I see it. The opposite of 3x squared is minus 3x, cubed. The opposite of x squared is negative x squared is plus x squared. The opposite of 4x is minus 4x. And negative 7 is positive 7. So I'm going to combine my x to the thirds. So negative 5 minus 3 is negative 8x to the third plus 1x squared. And then I have negative 3x minus 4x is negative 7x. And then 7 plus 4 is 11. All right, hopefully you got what I got. Oh, there's the answers. Good. All right, moving on. That was it for section 6.4. That was it. All right, now this section we're going to multiply with polynomials for 6.5. We're multiplying polynomials. Sometimes we'll have a monomial multiplied by a trinomial. Here we have a monomial multiplied by a monomial. Same thing here. So remember, if there's no plus or minus signs in between all of these numbers and letters, this whole thing is one term. This whole thing is one term. This has 3 different terms because I see minus and plus. So we're going to do a lot of distributing, and now we know the rules on multiplying exponents, right? Not exponents, but variables. What do we do with those exponents when we have the same base? What do we do with the exponents when we're multiplying 2 numbers that have the same base and we're multiplying them? The answer is we're going to add our exponents. So the leading coefficient is 1 right here. So don't forget that. So you're going to multiply negative 4 times 1. You get negative 4, and then x to the first times x to the second, you add 1 plus 2, and you get 3. So I get negative 4 to the third. Negative 4 times negative 3, we're multiplying the coefficients. So negative times a negative is a positive, and then x to the first times x to the first is x to the second. And then we're not adding like terms, we're multiplying unlike terms. So now we multiply 12 times negative 4, we get negative 48, and you can't drop that negative sign. And so we've just multiplied a monomial by a trinomial. Letter B, we're going to multiply things together that are like each other. For example, we're going to multiply the coefficients. So 5 times 5 is 25. Now this is a single term times a single term, okay? Here we distributed what's on the outside of the parentheses by every term on the inside of the parentheses. Here it's just one term times one term. Well, the only thing to do with these is multiply our 5s. We're going to add the bases, we're going to add the exponents that have the same base. Well, x squared times x to the 4th, we add 4 and 2 and we get x to the 6th. And then y doesn't get multiplied by anything. There's nothing over here. There's not another y. Okay? If you don't see plus and minus signs in here, You shouldn't end up with any. We saw plus and minus signs here, so we have separate terms when we were finished. Here's a single term by a single term equals a single term. Letter C, I have a monomial times a monomial. I'm going to multiply my coefficients. 5 times 3 is 15. X, there's no x's to multiply by, so I have x to the first power as part of my answer. And then I can multiply y times y to the fourth times y to the second, add those exponents, and I get y to the sixth. And that's my final answer, which is just one term. All right, so letter A, I have a monomial times a binomial. So I should end up with 2 terms in my answers. 2 terms. So I'm going to multiply 4 times my first term, x to the third. So 4 times x to the third, or negative 4 times x to the third is negative 4x to the third. And now I multiply this term, or this product, this number, I don't know what I'm trying to say, times this term. Well, negative 4 times 4 is negative 16. That's the final answer. 2 terms. Here I have 1 term times 1 term. So my answer should be how many terms? 1. So I'm going to multiply my coefficients. 2 times negative 6 is negative 12. There's only a single x, so I bring it down. I have y squared times y to the third. I add those 2 numbers, 2 plus 3, and I get 5. And my answer is 1 term. All right, how many terms do you see? 3. So when we're done, how many terms should be in our answer? 3. Okay? So we're going to multiply this number by every single term. So negative 2x times negative x squared. First of all, a negative times a negative is a positive. So 2 times 1, there's an invisible 1 coefficient. 2 times 1 is 2. X times x squared is x to the third. All right, negative 2x times 3x. We multiply our coefficients. Negative 2 times 3 is negative 6. X times x is x squared. And then negative 2 times negative 7. Well, negative 7 times negative 2 is positive 14. And then there's an x as part of our answer. Now that's our trinomial answer. And that's it. That's it, guys. So just remember, if you have a multiplication problem with 3 terms being multiplied by a binomial, your answer should be 3 terms. If you have 1 term times 1 term, in your answer you have 1 term. So that's why sometimes you end up with 1 term, sometimes you end up with 2 terms like this one, because you're multiplying a binomial by 2 terms. And sometimes you get up with a trinomial because you're multiplying a monomial times a trinomial. All right, so 6.6, basically we're going to talk about FOIL, multiplying using the FOIL method. And the other one even though there's several different objectives on here, the one that I really would like for you to identify or be able to pick out is if you're finding the products that are the difference of squares, and I will show you exactly what that means. All right, so first of all, the first question is, what does FOIL mean? So I'm sure somebody remembers FOIL from high school. FOIL. The F means you're going to multiply the first 2 terms. The O means you're going to multiply the outside terms. The I means you're going to multiply the inside terms. Mess that up. And then the L means you're going to multiply the last terms. So when you use FOIL, that's always when you're multiplying a binomial times a binomial. You have 2 terms times 2 terms. So you're going to always think of FOIL. In other words, you're going to multiply the first 2 terms. That's the F. The outside 2 terms, these are outside the ends, right? The inside terms, this is inside times inside. And then finally the last 2 terms. This is the last term and this is the last term. Okay? In other words, you're just distributing both of these numbers. You're distributing 2x times both of those. and then you're distributing 1 times both of these terms. That's all we're doing. We're distributing. But some people, if they use that little acronym, it helps them remember to get everything. All right, so first two terms, 2x times 4x. Our first two terms, 4x times 2x is 8x squared, because x times x is x squared. The outside terms, the outside terms is 2x times 3. So 2x times 3 is 6x. The inside terms is 1 times 4x. Well, 1 times 4x is 4x. And then the last two terms, 1 times 3 is 3. And every time you use FOIL, you should always be able to add those two middle terms. They're always going to be like terms. So we write down our first term. Our two terms in the middle combined, 6x plus 4x is 10x. And then 3 stands on its own. So when you multiply two binomials when you multiply a binomial times a binomial, you'll always get a trinomial. Well, that's not true. Okay, I shouldn't have said that because this one, anyway, it's going to look a little different. All right, we're going to do it the same way. So the first two terms is x times x. So first two terms, x times x is x squared. Now the outside terms, x times negative 6 is negative 6x. The inside terms is 6 times x, which is positive 6x. And then 6 times negative 6 is negative 36. Now, do you see that the two middle terms are always going to combine, but in this situation, they cancel each other out. They go away. So what we end up with is x squared minus 36. So that's why a second ago I said you always get a trinomial. That's not true because in this situation, the two middle terms canceled each other out. Okay, this is actually the special product I talked about earlier, the difference of squares. If you see two numbers, this is a perfect square. X squared is a perfect square because x times x is x squared. 36 is a perfect square because 6 times 6 is 36. And when you have the difference of perfect squares, basically it's what you get when you see something like this. You're squaring this number and you square that number. But we'll practice some more of those in just a few minutes. All right, anyway, letter C, we're going to do the first two terms. Well, the first two terms are 5x times 2x. 5x times 2x is 10x squared. The outside terms, 5x times 1. 5x times 1 is 5x. These two terms, 7 times 2x. 7 times 2x is 14x. And the last two terms, 7 times 1 is positive 7. So those two middle terms are going to be like terms, so we're going to add them together. So we have 10x squared plus 19x plus 7. And that's our final answer. All right, you guys try letter D. Why don't you pause the video, try letter D, and let me see what you get.